All right, 7.1 solved by graphing, and we're going to be using slope-intercept form. So this unit is on systems of equations, and a system is normally written with a little squiggly line here to show that they're together, they're grouped together. So we look here, and what we're graphically doing, graphically we're finding where do these lines touch, okay? So there's a few different special case scenarios that we want to go over. There is no solution, and there is infinite solution. All right. So if I tell you that the solution, if I describe a solution, that's the point where they cross. So you talk about two lines, it'd be that point where they cross. Think about it on your own. Where could a no solution happen, and where could an infinite solution happen? A no solution would happen on a graph where the lines are parallel. Parallel lines. Yeah. Now, graphically, we'll see it as parallel lines, or we'll see it as the same slope. Whenever we start doing it algebraically, what we're going to get is we're going to get some kind of thing that's like 5 equals 4. We're going to get some kind of weird statement like that, and we know that's not true, and then we're going to say, well, that means no solution. But we'll get to that in another lesson. Infinite solution, what could it be? Well, infinite solution is whenever we have two lines that lay right on top of each other. They're really the same line. So this is same line. Sometimes the way that this will be presented to you is it'll say like y equals x or 2y equals 2x, where you have two things that if you were to reduce, they would always reduce to the more simple one, right? That is a infinite solution. And so algebraically, whenever we start solving these without graphs, you'll get some kind of statement like x equals x, 5 equals 5, 7 equals 7. Some kind of statement that's like, well, yeah, no dip, this is true. That's whenever infinite solution comes into play. So we always need to remember that these two ideas are hovering in the background to where if you get some weird answer and you're like, I don't know what to do now, you need to probably revert to one of these two. All right, but a lot of these answers won't be these two, but I want you to know that they are there and they will be the answers to some of them. So number one, the way we're going to start off doing this is we're just going to graph them. So y equals negative 2x minus 1. Our y-intercept is at negative 1. Our slope is negative 2, so I'm going to go down 2 over 1, down 2 over 1. And whenever I solve by graphing, I normally try to put as many points on the graph as I can, hoping that it'll cross at one of these nice points. So there's all my points. Now I'll draw my line in. All right. Now we'll look at the other line. My y-intercept is at negative 4. My slope is at 1, so I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. And the question now is, where did they cross? They crossed right there. And the answer is going to be the point that's there. So what is that point? That is 1, negative 3. So that is a solution. All right, number 2. The top one, our y-intercept is at 1, our slope is 1. So there's my line. Ooh, that's not a very good line, but oh well. Our green line is going to have a y-intercept of negative 4, and it's going to go up 6. 1, 2, 3, 4, 5, 6, and over 1. Now, because I can see where they're going to cross, I'm just going to be done. I'm going to draw my line. And I now need to list that point. What is that point? It is at 1, 2. 1, 2. All right. Number 3. My intercept is at -2. My slope is down 1 over 1. It's -1, really. So there's my line. For my other line, I have an intercept of 3. My slope is 2 over 3, so 2 over 3, I could go up that way. But I'm going to need to try to go the other direction. I could go down 2 and left 3, and I hit that point. So my solution happens right here. That is the point -3, 1, right? I look at my x-axis to find my -3, my y-axis to find my 1. All right. Number 4. Intercept is at -1. My slope is -1. For my second one, my y-intercept is 4. My slope is 1 over 4, so I could go up 1 and over 4 that way, or I could go down 1 and left 4 that way. So here's my point. What is that point? That's at -4, 3. There's our answer. We can probably see that these problems also help you to graph lines much faster. All right, the first one here, our intercept is at -3. -3 down here. Our slope is -1 over 2, so we're going to go down 1 and left, or excuse me, down 1, right 2. Now the second line, that is a vertical line. So I look at my x-axis here. I put a dot on the -2, and then I put a vertical line through it. All right. Where did they cross? They crossed right there. That is at the point -2, -2. All right. Number 6. The first one has an intercept of 4. My slope is a -1/2, so down 1 over 2. The green one has an intercept of 1 and also has a slope of down 1 over 2. I think I said something special about ones that have down 1 over 2. So where's our intercept? And the answer is that we don't have an intercept. So let's look back up at the top. What happens if we have parallel lines that they don't touch? No solution. So our answer is just going to be no solution, right? So this one really you can see right at the beginning. Once you see that they have parallel slopes, you say no solution. Right? All right, number 7. I'll start off with the orange one. I have an intercept of 1, slope of 1/3, so up 1 over 3, down 1, left 3. My green one's going to be intercept of 4 and down 2, right 3. Yeah. Here's my intercept. And what is that? Or my intercept, I don't know if I should use the word intercept. My solution, there it is. I go right 3 and up 2. There we are. All right, number 8, finishing it up. Intercept of 1, slope of 1/2, so up 1 over 2. Oh, I guess I need to draw my line, don't I? And the other one, I go down to -4. And so my slope is negative, so I really need to go up 3 and left. So up 3 and left, 1, 2, 3, 4, and there's my point. All right, and that point where they cross is at -4, -1. All right, there we are. Now notice that we did not have an answer that was infinite solution, right? Infinite solution will happen if they end up crossing over each other, if the lines are the same exact line, okay? All right, that's that.